might think that it's strange to present a talk about the Amazon region within a session talking about tectonics. But we are finding a lot of evidence for tectonics in the Amazon right now, and we are having a lot of evidence to show that many changes that we see through time and also in the modern setting on the Amazon drainage basin is related to tectonics rather than climate. So the previous models that we have available, it's always considering that the Amazon drainage system is changing through time, mainly due to climatic changes. And what I'm going to show is that, this might be a little bit different. Try to convince you about that. So what I'm going to talk today is about this tributary of the Amazon. It's called the Madeira River, which is a main tributary of this Amazon system. And this tributary here, it goes all the way around here to, from southeast to northeast here, ending in joining with the Amazon River at this place here, right close to the Manaus area. This river is very different from the other ones that you can see here, other tributaries of the Amazon basin, because we have here the Purus and the Juá River, as you can see, very meandering system. And the Madeira River, similar to the Amazonas River, is quite different. It's made by very long, very straight segments, and we have also some meanders here, but it's a different type of meandering than we have for the other two here, for instance. So another thing that's very interesting here is that we have a lot of terraces making the margins of this river system, but these terraces are concentrated in some specific places, like they are very well developed in this area here, but over here in the rest of the area, and also upstream, we have very few, very straight, very narrow terraces. So I was wondering when I saw here for the first time why these terraces are so well developed at this specific point here, and then we start looking at some images to see if we could figure that out, and then we notice that we can see these terraces. You can see, like, I brought these two pictures for you to compare, because the remote sensing data are very helpful for us to, guide in an area like this one here. That's a very huge area, and you don't know how to start the research from. So this area here, you can see that we have optical images. You can't see the terraces. But if you get the digital elevation models, they are very good to show differences in terraces. You can map very well these terraces based on this tool. So we are using a lot of the the digital elevation model from the SCRTM databases to map these terraces. And you can see here we have in that area that I just showed you three main terraces. We have another small terrace that we can't recognize very well in these images, but mainly we have these three very well developed terraces. The main one is this one here that's located far away from the modern river. And we did some sedimentological studies in this area, and they are available, by the river banks, but also made a lot of drillings, very shallow drillings, actually not deeper than 50 meters only, not so easy to make drills in this area with our equipment. So mostly they are very similar. If you think about sedimentological data, when you compare all these terraces, the only difference is that T1, which is the one that's the more old, the more ancient one, this terrace is a little bit more coarser grained. We have some units here that's conglomerated to coarse grained sandstones, but we also have fine-grained sedimentation associated to these terraces, and also lots of mud. So sedimentologically speaking, they have no much difference in terms of lithology. But these terraces also, you can find a lot of channels associated to these terraces, of course, channels and floodplain, mud plugs associated to these terraces. As you can see, the terrace T2 it's you have a lot of morphology of meandering system that you can still recognize preserved in the morphology of these terraces, which we don't see more in the one that's located far away from this area. Terrace 1, I forgot to say, but we did a lot of collect a lot of C14 dating from these terraces, and the one that's located more distant, T1, it's about of an undetermined age between 43 and 32,000 years. So this is called years BP, and terrace T2 is 26 to 14,000 years, and it looks like this is the sedimentation associated to this second terrace. And for the terrace that's located closer to the modern river system here, we got ages that are younger than 12,000 years BP only, and it goes up to 3,000 years. And then we have another sedimentation that's the modern sedimentation that's younger than 3,000 years only. So we have a difference in morphology, and we have a difference also in topography, of course. We get altitudes here that's around 85 to 90 meters, not more than that. And then it goes down to the modern floodplain system. When we see these terraces, like I said, we have this model that the terrace down cutting and terrace infilling is formed by fluctuations between glacial and interglacial phase, which in the Amazon area is imprinted by differences in wet and dry, periods only. So, what I think is that we have the terraces here, so that's the arrangement of all these terraces that I was talking about. And if you compare this with the glacial and interglacial episodes, you can see that you don't have a very good match between these events of the terrace formation with the glacial interglacial times. So usually what we have based on the climatic model for terrace development, we have during the glacial episodes, we have terrace downcutting, erosion and terrace downcutting, and then in the glacial period you have, of course, the water table raises, and then you have sedimentation, a lot of sedimentation going on. And when you have the next time of dry or glacial episodes, you have also, another period of terrace downcutting. And then if we use this model here, you see that this doesn't work very well for this area, because you have lots of sedimentation. For instance, in the terrace T2 here, it took place mainly during the last glacial maximum, and which is when we are supposed to have main terrace downcutting instead of sedimentation. And you can see that even before or after the last glacial maximum, you have a lot of sedimentation going on. So the terrace formation didn't care much about what was going on with climate in this area. If you take a look in the terrace T3, it's the same here, because here we have the young dryas taking place, and terrace formation start a little bit younger, a little bit earlier than that, and then the sedimentation continued, up to in the late Holocene. And during this time, the sea level was, getting up, was rising, and so we had sedimentation during all this time, and also when we had the drier period here. So if we are going to trust in this age that we got from, this area, what I believe is that we don't see much matching, between these terrace formations, terrace downcutting and sedimentation, and with the glacial, interglacial episodes. So what I think is that we have other forcing mechanism going on in this area, which I will propose is related to alternations of tectonic activity, alternating with tectonic steadiness. And when you have tectonic activity, what happens is that you have a model more or less like this one here. We have faulty reactivations and a little bit of subsidence, and then when you have after the subsidence that you can create space for the sediment to accommodate, then you have some deposition of in these areas, the fluvial deposition, and when you have again another event that can cause some activity again in this terrace, in this fault, then you have again another period of terrace down cutting, and then that goes all the way around, forming this complexity and these different periods of terrace down cutting and terrace sedimentation. And the reason we do that, we think that the tectonics is a very important factor influencing the development of the Amazon drainage systems, because we have evidence for tectonics all over the place in the Amazon. Many people don't know about that, but actually the evidence for tectonics are becoming very clear, in these last decades. We have, for instance, this is the Madeira River. The Madeira River is established right upon a very important strike-slip fault zone that cuts all the way through this area here in the northeast to southwest direction. The main, as you can see here, the main fault system in the Amazon are these northeast and northwest, southeast oriented fault zones. So this is one thing. Another thing is that if you take a look at some image, if you go, for instance, the Google Earth image, you don't need to prepare an image, making a lot of processing, but get this image that are already, ready for observation. And you can see that if you look at the bottom of many rivers in the Amazon, 2 minutes, and also in the bottom of lake systems in the Amazon, you see these faults. They are all there. So these are from underwater, areas. So we have strike-slip motion, strike-slip faults here, and here you see the interpretation. It's all dominated by lots of fault systems, and they are better preserved underwater because then you don't have influence of vegetation, of course, and also pedogenesis that could change a little bit of this shape of these faults. So it's a very nice place to observe, these features here. Another feature that you can see here also is that we have a lot of earthquakes in the Amazon. Many people don't know about that, but they are there. So here is a synthesis about the seismogenic record for the Amazon. We have earthquakes with the magnitude up to 7, for instance, over here in some areas, not all over the places. But we have like this one here. These earthquakes were very important one from 1962. It shaken a lot the area around there. We have also whole fluvial valleys that have been displaced by faults. Lots of fault morphology preserved, like here in the Negro River, faults that are displacing quaternary sedimentation. And we have these huge systems that are the megafen systems in the Amazon that have been discovered in these last few years. And these megafens, they are also displaced by strike-slip faults. So, what I want to conclude here, because I don't have more time, is that fluvial terraces in the Amazon are very important archives for reconstruct depositional events in one of the main Amazon tributaries. So I think that the Madeira Terrace can tell us a lot about what was going on there in terms of erosion sedimentation. And this erosion and sedimentation, they cannot be accommodated very easily within the climatic model. And I think that fault activity was very important to produce these features and also to control the morphology of the Amazon system through time. That's all. Thank you very much.